Here is the setup for example 21.2. So the price of our good that we're selling is $9, rent is $1, and there's our production function. Let's go ahead and write out the generic form of the profit function. This is price times output minus the cost, which is wages times labor minus rent times capital. So that's the generic form. Now with the information we have, let's go ahead and write what profits are. So it's 9 times L to the third, capital to the third, minus wage times labor, minus R is 1, minus capital. Now with this, we can start taking our first order conditions. And the first order condition with respect to labor is equal to 3L to the negative 2/3, K to the 1/3, minus W equals 0. The second first order condition with respect to capital is 3K to the negative 2/3, L to the 1/3, minus 1 equals 0. And that 1, again, that represents the rent, which is 1. Now we can divide 1 by 2, the first order conditions, and this will lead us to K over L is equal to W, which implies that capital is equal to W times labor. Now with this, we can substitute that back in to the first order conditions. You can do either one. So we're going to plug it back into this first order condition where we see capital. And that implies that we get 3 L to the negative 2/3 times W L to the 1/3 equals W. Now we solve for L, and we will eventually get L to the negative 1/3 is equal to W to the 2/3 over 3. And now we can solve for L by itself, and we get L star is equal to 27 over W squared. Okay, so that's our labor demand. Now from this, we can solve for W as a function of labor. So wages are equal to 27 over L to the 1/2. And so those are our wages. Now when we think of the union's maximization problem, right? So the union's maximization problem, they are trying to maximize worker surplus. And this is equal to W minus the costs times L. So that's the generic form that the union's trying to do. So this is the union's problem. Well, now we have W. Let's actually get that to point to where we want it to point. There we have W as a function of L. And so now the maximization problem is the union is going to maximize worker surplus. They're going to choose the number of workers to hire. And this is going to be 27 divided by L to the 1/2 minus C times L. And we're going to take that with respect, that derivative with respect to L. So the first order conditions here, we get 1/2 27 over L to the 1/2 minus C equals 0. And now we solve this for L. So the L star for the union is equal to 27 over 4c squared. And that's how much the union, depending on what the marginal cost is, let's go ahead and make that just a little cleaner. Depending on what the marginal cost is to hire a worker, would be that number there. And now we know what L star is for the firm and L star for the union. Let's set those equal to each other. So we have 27 over W squared is equal to 27 over 4C squared. Let's cross multiply and cancel out. So 4C squared is equal to W squared. Let's take the square root of both sides, and W star is equal to 2C. So the optimal wage for the union is equal to twice times the cost. And that's how we can go through a numerical example to find the objective of, to find the wage and the number of workers that a union would want to hire to maximize their problem.